Module 2, monitoring and understanding your operating system, the Dig Deeper toolkit. Let's dive in. When we know something about operating system architecture, it is high time to play with the toys we have inside, using probably some tools we have provided by Microsoft or by some other vendors, allowing us to dig into the operating system internals deeper than usually we can observe from the graphical interface. Of course, some tools are presented within the operating system, are provided by Microsoft as a part of the installation, and I like to cover a couple of those, starting from Task Manager. So Task MGR being a very simple tool, I had a chance to cover it briefly. Of course, it is one of those, but we can find a couple of others, mainly command line utilities. Going through those in a random order, those I like to show you as exposing the really deep internals of the operating system. I can start with Filter Management Console as FLTMC. Mini filters are part of the stack for processing the data on your file systems mainly. So if I display my mini filters, I can see a couple of those being active, being part of the processing of every single request. So you can see I have some filter, for example, here for Sysmon. I like Sysmon. I will refer to this filter multiple times. With FLTMC, I can do a lot of things with every single filter and with the mini filter infrastructure. So, for example, I can display instances of mini filter. So, if I refer to the Sysmon driver again, I can say FLTMC, then instances, and then Sysmon DRV, and I can see -f Sysmon DRV. I can see on which drives and which devices within my operating system Sysmon is trying to listen, trying to report some operations. Here, if I display all my mini filters, the parameter attitude is about how high on the stack this particular filter tries to stay, effectively providing an order for processing stuff. Please do remember that for most mini filter drivers using FLTMC, you can also unload the driver. Here you have an option for this. You can unload the driver totally or detach the driver from particular volume. If we try to play with unload and Sysmon DRV, effectively we make Sysmon totally blind, as driver for Sysmon. Sysmon DRV is providing the knowledge for the Sysmon what is happening within the operating system. The Sysmon is a whole broad topic for another time, but we can play. For example, if the antivirus developer is not smart enough, we can unload the driver for antivirus, effectively making an antivirus blind for things happening on the volume. And of course, managing, playing with FLTMC requires administrative privileges. If I am a regular user, FLTMC will not allow me to do that much things. FLTMC, you can see I'm not allowed to do this, as this is definitely something requiring admin permissions. Another command being built in the operating system, being crazy powerful, and referring to another area we will refer later on, is fsutil. fsutil is a utility for playing with the operating system volumes and file systems. We can change properties of the drive, we can change properties of the NTFS file system, we can read some data, we can manage volumes, enabling, like the first option, the creation of short names on the volume or disabling it, playing with, for example, journal files and so on. And we will cover this topic when referring to the storage management, and definitely it's a powerful utility, but I will play with it deeper when it comes to the proper moment within the course. If you do not like Task Manager, but you still want to play with tasks with your operating system built-in utility, we have pretty powerful and very useful task list utility. Simply displaying all active tasks. You can see the predefined set of columns here, but if you specify task list slash quotation mark, you can easily see we can display different things related to our tasks running. We can perform some filtering, like for example, displaying only applications which are not responding, however it means in practice. We can refer to some applications with, for example, CPU time greater than some time in hours, so we can observe application taking too much CPU time and so on, and all in a scripted way. If we script a listing of the tasks, we can use task list as I demonstrated. We can also use a very nice utility being designed for terminal services, but is present everywhere, query. With query we have parameter process. With query process we can display our tasks as well in a bit different way, in a way more oriented on terminal server users. I can also filter, for example, I can say query process and then specify notepad.exe, displaying all my notepad.exe instances within my operating systems. And if I have my processes, especially their PIDs, as those are unique identifiers in particular moment in time, I can play also with another utility we have built in, which is task kill. Task kill, and I can do task kill slash process identifier and specify 99232, and one of my notepads probably will disappear after such command, if only I do not make no typo within the syntax. And of course, one of my notepad was killed, and we can script it. It is up to you to create, for example, a process taking some CPU, then detecting this process using task list, then killing it using task kill. You do not have to play with graphical interface. You can script it, you can automate it, but please be aware it has full powers against your users, and it may lead to some data loss if you are well, too brave and doing things not really needed. Just to mention a couple of other very powerful things here. The query, it is not only about processes, it's also about users and sessions. Term server is about finding terminal services on the network, so it is not about system internals, but we can do query session to enumerate sessions we have within the operating system. So I have one RDP TCP connection listening to some new connections. I have my user working on the console, and I have some special sessions for services, isolating it in terms of another session, like separate namespace, separate message space for services only. The change introduced in Windows Vista and in the kernel version 6. So I have like two sessions active and the third one being ready to be connected. To mention very quickly a couple of other things, I will refer to this when talking about I/O operations. We have powerful utility called mount_vol. Well, it is comparable to Unix mount command. I can display how my volumes are being mounted within the operating system. So this volume is being mounted as C, this one is and so on. As you can see, I have two volumes having no points, and this is absolutely not necessary in Windows to mount every single volume. It is visible, for example, on servers when you can have more volumes than you have letters within the alphabet. So you cannot provide a letter for absolutely every single volume if you create more than 25 volumes in your system, which is perfectly possible. So here I can play. I can manage my volumes, my mounting points. /D is pretty powerful thing, as you can unmount the volume from your environment, and it's absolutely possible, for example, to unmount C volume. Please do not do this within your production environment, as mounting it again will require mount vol command. So you can play with this. I definitely recommend playing with mount vol and unmounting all your volumes, or mounting your volumes as mounting points as directories instead of drive letters. But please be very careful. We are digging really deep. We are touching the basics of the operating system and the foundation of the operating system, and it is relatively easy to shoot into your own feet playing with those tools. When it comes to the storage, we also have VSS admin, the command for managing snapshots, one of those commands working different way on server and on workstation, which is well, very nice touch from Microsoft. And it's also very powerful. We will refer to VSS and the whole structure for snapshots when we will discuss storage subsystem. One more to be discussed here, touching some operating system internals from totally different perspective we usually see at the operating system, is the PowerCFG. PowerCFG is a utility allowing you to play with your power saving schemes, like you can list those, you can display the content of the power scheme, etc. The stuff you can do with graphical interface, after how many minutes your screen will go blank. It can be configured with PowerCFG, but at the same time power management is way more complex inside the operating system. Actually, if you plan to develop your own driver, managing power states and transitions between power state is one of the most complex things to be provided by the driver code. But here we have also some other things related to the operating system internals. For example, I can do PowerCFG/A, displaying which sleep states are accessible by my operating system. So I can see those are not permitted, those are permitted right now by this hardware, this installation, and this configuration. Another thing I can do here is reporting about battery, how battery is being used, something which may be useful. We can see which requests are currently active, power CFG requests, and you can see no request, as this is not something active from within this level. At the same time, you can see an information that audio is currently in use, which is not that surprising, as I'm recording this session right now. Yet another one is device query, is yet another way of asking your operating system about devices you have installed. PowerCFG is not about devices and drivers, but with device query you can easily do this. You can analyze why your operating system is up and running. So if your system is running, you can first verify how it happened. So the command for this is last wake, and you can see I pressed the button and my system was started to be active after pressing the button. It is device oriented and the driver oriented, but it is not that hard to be scripted, and you can react different way if your system is awaken automatically or by some timer or by some another driver, which may happen. For example, it is perfectly normal situation. You close your laptop lid, then you put it into your bag, and then your system is for some strange reason awaken again. Here you can verify how it happened. It may be about mouse being disconnected, about some other device, about modem, whatever, something not allowing to fully go asleep and then waking the system again. Please do remember about one very powerful utility being built into the operating system, which is WMIC. WMI console. WMIC is pretty complex utility, being interactive console and being a scripting solution as well. Here we can use some aliases, for example WMIC process, and I can specify which properties of the process are interesting for me. For example, name, and then a process ID, then thread count. And I have a nice table with my processes, the ID of the process and the number of threads being present and running within particular process. So please do remember that WMI, and we'll refer to WMI later on as well within this module. With WMI we have a lot of information about the operating system internals, about the hardware, etc. So we can play with those easily, and we can obtain some information from WMI, possibly filtering it, exporting to a file, managing it, creating reports, etc., etc. The huge thing about operating system internals monitoring is coming from Microsoft and is made by Mark Russinovich, and it is about sysinternals, obviously. Sysinternals.com. This link is redirecting you to Microsoft, to the proper place within TechNet, and here you can see the stuff with all updates, with some blog posts and so on. I definitely like this page as is trying to explain how we can use particular utility, but if you are familiar with those tools, usually we are going to live sysinternals.com, landing on this very nice page. We can just play with tool after tool. Please be aware that, well, running all those tools is like it may be a risk. If you do not know what are you doing, you will turn yourself into a monkey running with a razor blade. Please be aware that some tools being provided here are left forever after being developed, mainly by Mark Russinovich. For example, I have some files from late 90s. Those are about switching keys on the keyboard as once the keyboard appear with unusual places for keys. So it was a tiny utility in Windows NT 4 times, replacing a functionality of two keys to use control instead of caps lock and vice versa. Here we also have some other tools. The best thing you can do with those tools, of course, I will not cover every single tool here. I will refer to multiple tools from this set later on when coming to particular topic. I had a chance to discuss Process Explorer, Process Monitor. I referred very quickly to Sysmon. I also referred in the previous module to WinOBJ, etc., etc. If any of those tools is useful for us, I will definitely refer to it. It is way better than going tool after tool. If you try to play with this view with LiveSysInternal.com, there is a couple of surprises for you if you try to find folders here, as most of those are files, but also we have a couple of folders. Please play trying to dig deeper inside those folders. Are some very nice stuff, like additional stuff may be provided there. The huge thing about monitoring is about digging into system internals, not necessarily about monitoring, is provided for developers. As developers developing applications for managing internals of the operating system have to somehow play with really deep system properties. And for such purpose, we have a set of Windows kits. And basically, we have a couple of those. ADK is for preparing Windows images for installation. Very useful stuff, but not that much about system internals. And we have SDK and WDK. WDK is the most tempting one. And we can install it in the form of nice wizard asking you about which part of the WDK you would like to install. But I definitely recommend you to download Enterprise WDK. Enterprise WDK is a one big ISO image. Big, I mean like next to 6 GB. If you mount it, you can observe all those tools. I have this ISO file mounted. You can observe all those tools being present here and being available for you to use them right now from the ISO file instead of install them as a part of Visual Studio, installing WDK and so on. Just to refer to one of those, quite commonly referred in different scenarios, utility for signing binary files, the sign tool. Sign tool is a utility allowing you to play with digital signatures. I prefer PowerShell, but sign tool has its own beauty. I can do dir the sign tool.exe with subdirectories and in a bare format, and you will realize easily that sign tool is provided in different versions here as a part of the ISO file. There is huge set of tools, and I will also refer to those. Please play with those on your own, but at the same time I will use it during the course as well, using them for different scenarios. During the previous module, I referred to Windows Performance Analyzer and Windows Performance Recorder. Those two tools are part of WDK, so you can install those from this location if you want to. Another set of features here within WDK is about debuggers. Today we also play a bit with debuggers, so this is how we can get those debuggers. If I need to refer to third-party stuff, I would like to guide you into two directions. The first one is very nice open source utility, Process Hacker. Process Hacker is a replacement for Process Explorer, or alternative for Process Explorer. Some people like it because it's open source. To be very sincere, it's a bit more powerful than Process Explorer, and it has some nice hacks, like running your process on behalf of another user with a process already present within the operating system. It has more powers. The only thing with the Process Hacker I usually mentioning is if anything fails on your server, if someone will realize it was a Process Explorer on your drive or Process Explorer running, and the Process Explorer is obviously downloaded from Microsoft and is digitally signed by Microsoft, then you are on the good side. But if someone will realize that you run something with hacker within the name on the server, probably you will have a lot to explain to people responsible for the stability and support for this particular machine. Another place I like to guide you is the Nearsoft stuff. Here we have mainly system tools. We also have some maybe programmer tools as well, and some forensic tools. Mainly system tools here are about going deep insight into operating system stuff. In most cases, we can obtain the same information we have from Nearsoft tools using different ways, using built-in tools. But with Nearsoft stuff, it is way easier. It is nicer and provided to you in nicer form. And the great thing is all those tools are free, which makes using them way nicer, obviously. And if we refer to most powerful tools we have within the operating system, we have to talk about debuggers. As with debuggers, we have a lot of powers allowing us to play with everything that runs within the operating system. If you install Windows kits, you will see a couple of WinDBG, the classical WinDBG, and I also have installed WinDBG Preview, being a store application. And WinDBG in theory is a graphical utility. I can try to display it. So I press F6 to attach to a process. I will attach to Notepad here. Of course, I have to find it on my list. It is here. If I attach to Notepad, this is how the graphical interface for this utility looks like. Well, in theory, it is graphical utility, and at the same time is not that friendly, and you should know what you are doing. QD, and I will detach from debugger, the debugger from Notepad. My Notepad is still alive, which is a great news, which is not that obvious. The great thing with debuggers is you can attach debugger to the kernel of the operating system. Your kernel must be run in a special mode, so you have to add an entry to BCD using BCD edit, and if your kernel is running in the debug mode, you will obtain a nice message on the screen. Your kernel is running in the debug mode, as it exposes every single secret you have within the memory to someone attaching to the kernel with the debugger. It is why it is like a hard-coded message being displayed on the screen when you debug your kernel. And I definitely recommend you playing with kernel debugging. We will touch some places, but before you start doing it in production, I can recommend you a kernel debug to virtual machines, which allows you to interact with both machines. And there is great utility being provided by sysinternals. So for the first time, we are referring to this huge library of tools. C program files, sysinternals, as I have all my all sysinternals tools being downloaded, LiveKD. And LiveKD is creating a snapshot of your memory and then is connecting the WinDBG or another debugger to this snapshot from the memory. The bad thing about this approach is you have read-only access to your operating system kernel, and the best thing about this approach is you have read-only access, so you cannot destroy anything. If you try to run it, it will tell you you can use -W for launching WinDBG, but please do not believe it. If I do like this, it will say WinDBG is not found, but I can provide a debugger with -K, and as you can see, my WinDBG is within the is already installed. You observed it within the start menu. So dear C program files x86 as kits are installed there. WinDBG dbg.exe/s/b. I can find my x64 WinDBG. So I can do LiveKD -K and then provide a path to WinDBG, and the snapshot will be created and WinDBG will be launched, and I will obtain right now the live access to my operating system memory and internals. For example, I can list all my running processes, process 0, 0, 0, and here you can see all my processes being present in the operating system. If I want to refer to some process, I can switch to this particular process and obtain information what is within this process. I was not able to run LiveKD with the store version of WinDBG, but in the same time you can see here on the screen on the title of WinDBG, actually WinDBG is running with livekd.dmp file. So if I launch WinDBG, this one, if I select within this utility to open a file with a dump, so I can open dump file and see Windows livekd.dmp. I can open the dump being created with livekd with this nice utility, and you can see the difference. It has icons, so well, it is not that classical, but at the same time it's a bit easier to be used by someone not very experienced. Please be aware that the internals of every of those tools is exactly the same, and it is working exactly the same way. And probably there is a better and nicer way of running livekd with new WinDBG, but this is the way I'm using so far, and it's working. I will stop it as it takes a lot of time. Debug and then break, and I can switch to any of those processes. Let's pick some classic process. WinDBG itself is not a bad example. I will copy the address and I can switch to this process context. Control V, and now I'm within this process. I can display, for example, process execution block, seeing all the data WinDBG has about himself. You can see you have information somehow comparable to what other tools for digging inside the operating system, including Process Explorer, can provide you. And of course we can go deeper and deeper. Here you can see which DLLs are loaded under which place within memory. You can observe what is the copy of the environment, what was the image file, what is the Windows title of the when the process was launched, etc. You can also easily display loaded drivers. Here, seeing some properties of every single driver here by clicking on it or by providing a name with the proper syntax. WinDBG comes with debugging help. Maybe I will go this way. I will go to Windows Kits, and within Windows Kits I can see debugging help. Here you have some help about how it's working and about some other help about debugging. It may be useful in practice to go deeper and to understand more. I will refer to this debugging help later on when playing with blue screens. Okay. I will not launch WinDBG again. I will exit WinDBG. It was about playing with the kernel, but we can also go to process internals. I have my notepad up and running here. I will launch WinDBG, the preview version as the nicer one. And instead of opening a file I have on the drive, I will press F6 and I will connect to the notepad process. So I will sort by process name, I will refer to notepad, and I will try to play with notepad, and I will attach here. And right now I have broken the notepad threads, and I did a DBG breakpoint, so I can manipulate with the process. For example, I can display CPU registers in the current state. I can display some region of the memory. My notepad is not that much alive anymore, as I have stopped it to provide some commands here, so it cannot process it as its threads are not running. I can verify threads within Notepad. I can see there are three threads actually. I can verify the process execution block of this process, seeing how my process is defined inside. One of the interesting things I can do with debugger, and this is the purpose of the debugger, I can play with some traps. If I do BL, sorry, it's about nice syntax. I can see it is only one defined for DBG breakpoint, but I can define here some breakpoints, and when process is running, I can make the process running using G, like go, or by pressing a nice icon here. And you can see my notepad is alive again. I can break again into it, and I have full power here again. And I can define a new breakpoint, BU, NTDLL, so the kernel part, you should remember it. The NTDLL is responsible for the kernel, and I will create a breakout on one of the functions, ZW write file. And if I do this, and if I do BL, I can see I have two breakpoints. And this one is typical breakpoint, and this is about, I define it for ZW, but it's created for NT-write file, the official name. And if this function about writing a file is invoked by the process, the debugger will pop out, blocking the real execution. And I can press G or click go, and my notepad is running again, and here you can see the notepad is alive. If I click on saving file, probably some breakpoint will happen. I click on file, save as, and you can see my notepad is not alive, and my WinDBG started to be active. And the question is how it happened. Before I wrote a file, how it could happen, the breakpoint for writing a file is active. I can verify it very easily. There is a very nice command in WinDBG called K, and K will display you a call stack. In the meantime, symbols are being loaded, but it is not that long time here. So here you can see the full stack, and the function NTDLL NT-write file was actually invoked, and you can see how it happened in practice. Actually, it is because if you open any folder, some write operations are happening, for example, for updating the last accessing date for folders. If you have thumbnail caching for displaying nice icons for your files, those are updated when you open the folder. So it is a lot of write operations happening when you click on any folder, and you told your debugger to break on any of those. If I click go, now it is again doing something and stopping again. Now I can again ask about the stack, displaying me how it could happen that again some write is happening and what happened here. If I want to go deeper, I can observe, for example, parameters being passed to through the stack to the proper function, seeing which file is being written with which parameters and so on. It may be quite interesting, for example, if you create a trap for create a process with logon W, and then you can clear text read out of the stack parameters including username and password. And of course we'll refer to this later on when talking about security. I can go, and every single write something, my execution is blocked. So I can display the list BL, and I can click, for example, disable on my NTDLL write file, and my trap is no longer active. I can click go, and my debug is running, and nothing breaks its execution. And here, if I break, I can specify QD again and detach from my debug. Debug is not connected, and I can close it, and my notepad is again alive. One of the nice things of WinDBG is it comes with a library for debugging, and this library is very, very useful, as it has a possibility to work together with Process Explorer and other system stuff. As you can see, I specify the path for debuggers dbg-DLL, and I configure path for my symbols. And what does it mean? If I launch my very advanced utility, if I load a DLL, every single DLL has a table called export list. If I go here to the depends, I can open something from the history. This one is not the bad one. Probably some errors will appear, okay, but you can see here a list of functions being exported by the DLL under particular addresses. So if I know that the execution of the code and the map is saying this function name stays within this area of my DLL. So if I know my code is being executed here, I can do a reverse mapping and saying I'm using this particular function from this particular DLL, so I can decrypt somehow what my application, what my process is, or my thread actually, is doing. But when it comes to the .exe file, it has no export list. Of course, it has some modules inside responsible, some parts responsible for some different functions. For example, if I run cmd, there is a part for going through the tree of directories, and when I do dir/s and looking for a file, and it is probably here. But there is no way, if I know that the execution is happening here, which function I'm using. And Microsoft is nice enough to provide us a bunch of PDB files called symbols, and PDB file is like external map of this function is under this address, and so on and so on. So having PDB files, having symbol files configured, you can obtain an information about what your .exe file is doing, even if it's something, some code from the executable file, not from the DLL. If I do dir c everything ASB going to the full dir of my C drive, if I find this particular CMD here, you can see it here, I can open it and go into the stack, and here you can see display bar as a specified /b parameter, you can see walk tree, etc. And this information is not taken from the CMD itself, but is taken from the symbols file I have configured. The configuration of symbols here, it is pretty well documented, but I'm using cache from my C symbols, and if something is not present within the cache, I'm downloading a symbols from a special URL Microsoft provided for us for such purpose, to make us happier. If I try to go for some properties of some other software not being part of the Windows operating system, well, probably we will be out of luck. Sometimes Process Explorer can try to guess what to do. I will try with this one. Here you can see there is something from this .exe file, and you can see it is .exe plus some area. So here, what Process Explorer is telling us? It is telling us that we have .exe file, and within this file there is a start of this file, of the data, of the code side, plus some offset. But what stays here, no one has an idea, as we have no symbols provided for this particular file. Of course, they are not downloadable from the Microsoft URL. Maybe developer provided them for us. If we go for a stack, you can see if it comes to the third-party executable file, we have no idea about function names. When it comes to Microsoft stuff, we have this provided by symbols. So configuring symbols will make your sysinternals tools way more powerful. So I tried my best to go very quickly through most useful stuff being helping you with digging into the operating system. Please be aware that we also have a lot of PowerShell, and PowerShell can be very powerful. I referred, for example, to WMIC previously. We have get WMI object possibly giving us a lot of knowledge about what is happening within the operating system. For example, Win32 thread, and select everything, and then out grid view. If I run it, I will obtain an information about every single thread being active within the operating system. How long the process and the thread is active, what is the ID, how long the thread was active within the kernel mode, within the user mode, what are priorities, current priority, base priority, what is the process PID for related being owning this thread, what thread is doing right now and for which reason is doing such thing, and so on. So I have one table with all those rows about every single thread within the operating system. If I run Task Manager, I can easily see on the Performance tab, I have 4,000 something threads. So it is definitely covering all those threads within this table using WMI. This is pretty good way of playing with WMI. Another thing is going directly to some Windows API functions. I will not try to explain this particular piece of code with PowerShell I have here, but here you can see I'm creating all those structures required by create process function. Then I'm importing particular DLL being responsible for create process with logon W. Then using this script, it is a script in PowerShell exploiting bug MS16-32. Being a regular user, I can easily elevate to a local system using PowerShell only. Please be aware, and here I'm a local system. If I simply run CMD from here, and well, it's not the best idea, start from the ISE, but if I do who am I /all, I can see I'm a regular user with very limited set of privileges. So being a local system is absolutely not accessible for me. But by digging deep enough into operating system internals, I can exploit some bug and obtain such privileges. Of course, it was fixed by Microsoft about 2 years ago. So, if your systems are patched, then you can easily verify other stuff with PowerShell. That's basically it. Have fun with your toolset, and we'll use it heavily later on during our next modules.